This is the notes for going over laws of exponents over day 2 or the extended version of them. So previously we learned all of the laws separately. We learned the power law, the product law, the power of a product law, and then the quotient law. These are also known as rules, so you can hear them also be called as product rule or power rule. All right, so we're going to put all of these laws together. So just to review, we're going to go over the formulas for all of these laws. So the product law says that I have two things that are being multiplied of the same base. I can add those exponents together. So if I have a to the m times a to the n, okay, remember same base, right? Remember the base is the larger thing and the exponent is a smaller thing. So the base here in this case would be a. If they are the same base and the bases are being multiplied, then the trick or the shortcut is that I would add my exponent. So m plus n. Okay, the power law is the one where it says if I have a base raised to an exponent raised to another exponent, right? So we have a base raised to the exponent, so a raised to the power of m, to another exponent, the shortcut says I would multiply these exponents together. So I'd have m times n. Now you want to think about this as you're seeing parentheses and you want to get rid of them, so you distribute. And remember, distribution is the operation of multiplication, so you want to make sure you're keeping that in mind. When you're distributing, you're multiplying. So that's the difference between the first law and the second law. In one of them you're adding, one of them you're multiplying. You only multiply when you see those parentheses and you're moving those numbers in. Now, power of a product law is a combination of the previous one and kind of the first one as well. So this one says if I have two bases inside my parentheses raised to an exponent, okay, so I have two powers raised to an exponent, that says that that exponent is going to be distributed to all the exponents on the inside. So this would be a to the m times b to the m. Okay, so again, these are technically being multiplied together, but I don't write the multiplication sign. It's stated that it's already being multiplied. Okay, and remember when you're writing these exponents, make sure it's pretty clear that it's an exponent. You want to write y squared, not y2 like this. So you want to make sure your exponents actually look like exponents. Okay, so this is basically taking the exponent that's on the a and the b, which in this case is 1, and you're multiplying it to those exponents and distributing it in. Oops. Okay. And then the last law here, which is the quotient law. Quotient law says if I have a base raised to an exponent divided by a base to a different exponent, those bases must be the same, but I can combine them by subtracting. So this would be a m minus n. I would subtract them. And the way I have you remember this is, how do I know the difference between add and subtract? Well, when these are right next to each other, I can add them. Whereas these are on opposite sides, I would subtract them and get the difference in between them. And the way I told you about this was looking at that division bar, kind of like a giant minus sign. You're going to subtract the exponents. The base stays the same. You still have a base of a, but you're subtracting the exponents. And also, if you have a divided by b, so you have two different bases raised to an exponent of m, okay, this law says, same thing, quotient law, says that if this is the case, then I would distribute the m to all of the bases on the inside of the parentheses and multiply them to those exponents. So the exponent on the a is a 1, the exponent on the b is a 1. So I would distribute that m in to all of them. So I would have a to the m over b to the m. So that's really important as well. These are the same thing, so I'm distributing that m in essentially. Okay, so we're combining all the laws together here. So we're going to start with number 1. Number 1 is 2x cubed n times 3n squared x to the power of 3. So when you're looking at exponents, it's helpful to look at them as separate things. So you want to look at each thing individually before you combine all of them together. So I noticed that there's a multiplication sign in the middle, so I'm going to split this into the left side and the right side. So looking at the left side over here, I'm trying to think of anything I can combine or simplify with just this left side alone. But there's nothing I can do on that left side, so really there's not much I can do, so I'm going to leave it as is. So I'm going to go ahead and just leave it as 2x cubed times n, and then multiply to whatever's going to happen over here. Well, over here, can I do anything to simplify this side? Well, I see that I have parentheses, so I try to get rid of those, right? So I'm going to try to get rid of these parentheses. Now, in order to get rid of these parentheses, I want to distribute this exponent of the 3 in. Now, remember, when you're distributing that exponent of the 3 in, you're doing it to all of the exponents that are on the inside. So before you start, you want to identify all of the exponents on your variables and bases. So we have 3 bases inside these parentheses. The 3, the n, and the x are individual bases here. Okay, so what's the exponent on the 3? It's a 1. The exponent on the x is a 1. The exponent on the n is a 2. They wrote it down for us, so there's no need to really think there. So we're going to go ahead and simplify this and distribute that 3 into the other exponent. So this would have a base of 3, and then when I multiply the exponents, 1 times 3, I get 3. I'm going to multiply the exponents here, so I have n to the 6th. 2 times 3 is 6. And then I would multiply the exponents on the x as well, so x to the 3rd power. Now at this step, there's a couple things I can do, right? So here the parentheses are gone, so both sides, right, individually, both sides are as simple as possible. So now it's time to combine the whole thing. But before I do that, I noticed something. I can actually simplify the 3 to the 3rd here. I can simplify this guy. So I'm going to go ahead and rewrite this down here because I haven't done anything to it. But what is 3 cubed? I can type that in a calculator. Anything that's a normal number, you can type in a calculator. So 3 cubed is actually 27. And then I have n to the 6th, and then z to the 3rd power. So again, the exact same thing as I had in the previous line, I'm just making 3 cubed become 27. Now once I'm at this step, you can combine things that are like bases. Or wait, why did I make that a z? I'm going crazy. It is, as you can see at the very top left, it is 10:27. It's not that late, but it's late enough for me to make mistakes like this. So, all right, it's an x, not a z. I'm so sorry. All right, so now you're going to look for like bases that you can combine with each other. So, as I'm looking at this, I'm like, hey, what things can I combine? Well, I can always combine normal numbers together. So 2 is the regular number here, and 27 is a regular number here. Now, what would I do with these two numbers? The question is, do I add them? Do I multiply them? What do I do? Well, here you would multiply them. Because you see there's a multiplication sign here. Everything here is being multiplied together, so you want to multiply these. 2 times 27 is going to give me 54. Okay, so I get 54. 2 times 27 is 54. And I would double check that in my calculator, so I'm not going to go crazy. 27 times 2, yes. Okay, so I get 54. And then I'm looking for other like bases. So the next variable I see is the x here. So I'm looking for any other bases that are also x, which I do have in this case, the x to the cube. Now the question is, would I add these exponents or would I multiply them? Well, in this case, I would add them. There are no parentheses here, so there's no way I'm supposed to be multiplying. The only time you multiply exponents is when you are distributing. So in this case, I would add the exponent. So this would be x to the 6th. I'm adding them. There's no parentheses, right? I'm not distributing the 3 to the 3. They're not being distributed. Okay, and then the next base that I see is the n over here with the n to the 6th. So I want to combine those. Now remember, what is the exponent on that black n? That exponent is a 1, so there's really a 1 there. So would I add the 1 in the 6th or would I multiply the 1 in the 6th? I would add them. No parentheses, I'm not distributing, so this would be n to the 7th. Okay, now how do I know I'm finished and I'm complete? Well, when you have at the very end and you can't combine any of your bases together, you're finished. Well, 54 is a base, x is a base, and n is a base. They're all separate from each other, so I'm finished because I cannot do anything else to this problem. I'm going to go ahead and move that over there so we have some room. Okay. Number 2. Number 2 here, you'll see you have 3 separate parts. Now, it's again easy to look at things in separate parts before you look at it as one big whole picture. Okay, so we're going to go ahead and look at this first section. So when I look at this first section, I see 4w to the half, z to the 2/5. Okay, nothing I can, whoa, that's not what I meant to do. What's happening? Is this a phantom? What's going on? Oh, that's weird. Okay. All right, so I'm going to go ahead and box this and put this over here because that was weird. All right, now I'm looking at this first section. Now, none of these bases are the same. The 4, the w, and the z are different bases, okay? So you cannot combine those together in any way. So I would move on. Let's look at this next section. Again, 3 separate bases that have nothing to do with each other. Okay, so there's nothing I can really do there. Okay, what about this last section? Again, there's nothing I can do individually with these. So now it's time to combine. So I see that there's no parentheses here, so there's no need for me to get rid of parentheses, so I can just go ahead and shove everything together. So Just like in the previous problem, you're looking for bases that are the same that you can combine together. So, for example, look at your regular numbers. You're going to combine all of the regular base numbers together. So 4 is a regular base, just a regular number. 5 is a regular number, and we also have -2. So 4, 5, and -2 are all similar bases. They're just regular numbers. So I'm going to go ahead and combine those. So I would multiply these. Now remember, you're multiplying. Those little dots mean you're multiplying them. 4 times 5 times -2. 4 times 5 is 20. 20 times -2 is -40. Okay? 4 times 5 is 20. 20 times -2 is -40. So I've combined all of those. So then I move on to the next base that is the same. So the next thing I see is a w. So I'm going to go ahead and combine all my w's together. I have w to the 1/2, w to the 5 halves, and then I have another base of w, which is 2 here. Now, would I add or multiply these exponents together? Because here we're talking about exponents, right? So with the blue numbers, there were no exponents. I was just multiplying them. They were normal numbers. But here I have variables, and I'm combining them. So I have w to the 1/2 times w to the 5/2 times w squared. So the question is, what do I do with those exponents? I would end up adding those exponents. There's no parentheses here, so I wouldn't be distributing them to each other, right? We're not multiplying them. We're going to add them. We're going to add 1/2 plus 5/2 plus 2. So if you have a graphing calculator, go ahead and type it in your graphing calculator, but I'm going to go ahead and type it in Desmos because that's the tool that I have right now. So I'm going to go ahead and type in 1/2 plus 5/2 plus 2. So 1 divided by 2, 1 divided by 2, which is 1/2. And I want to make sure I tap outside the fraction so I'm not in the denominator anymore, plus 5/2, 5/2, 5/2, and I want to tap outside the parentheses again, plus 2. So 1/2 plus 5/2 plus 2 gives me 5. So this equals 5. So when I add up all of those exponents on the w's, I get 5. So I'm adding them all up. Now this problem might look scary because of the fractions, but you treat them exactly the same as you would treat any number. I know that there's no parentheses here, so I would add the exponents. I'm just going to add them all up. Okay, now the next base that I see are the z's, and so I want to go ahead and combine those z's. Now same thing here, I would want to add these exponents together. So I have z to the 2/5 times z to the 3/5. So in the end, I'm going to end up adding these exponents together, right? So we're going to do 2/5 plus 3/5. I'm adding these together. Now, if you don't know what this is, again, use a calculator. This should equal 1, though. So 2 divided by 5, tap outside the fraction, plus 3 divided by 5. That's going to give me 1. So I get a whole 1 here. Okay, so what does that mean for my exponent of z? It means when I add those exponents and combine them, I have an exponent of 1. Now, am I required to write that 1 there? No, you are not. So really, you have -40, -40, w to the 5th, and then z. Okay, you don't have to write the exponent of the 1, because typically we don't. But if it helps you think a little bit, then that's okay. So that's how you would do number 2. Again, I try to do these examples very similar to your homework and what you'll see on tests and quizzes, and even on STAR tests. All right, move that up a little bit. Moving on to number 3. Now again, number 3, you always want to look at everything in parts. So I'm going to look at the first part of this over here inside the parentheses. Can't do anything to that by itself. Can't do anything to this by itself. So then I'm going to move on. Now before I end up distributing this 2 in, you want to look at the parentheses as a whole first, okay? Always simplify before you do anything crazy, all right? Always do parentheses. PEMDAS says to simplify, you do parentheses first. So inside the parentheses, because individually, I can't do anything to them individually. The bases aren't the same. I can't combine anything. But as a whole, I can actually combine some stuff here. So you're going to look at your big bases together, so your big numbers. So I have 3 here. You're like, well, there's no other number here. Actually, what number is in front of this t? It's really a -1, right? So you're looking at your bases. So your regular number bases, you have 3 and you have -1. Well, you're going to multiply these because it's a multiplication sign. 3 times -1 is -3. Okay, so we're multiplying those together. And again, how did I know there's a 1 there? Remember, when they don't write that number there, there is really a 1 there, so don't let it fool you. Okay, and then I have the next base of t, so I'm going to combine the t's together. So I have t to the second and then t to the first. If they don't write the exponent there, there's really a 1 there. So what would I do with the 2 and the 1? Would I add them or multiply these exponents? I would add them. So yes, there's a set of parentheses, but they're on the outside, and we haven't done anything with the parentheses yet. We're inside the parentheses right now, so pretend like the parentheses aren't there, right? So I have t to the second and t to the first. If I were to combine these, I have 3 of them being multiplied together, so I have t cubed, because 2 plus 1 is 3. I would add the exponents. Okay, next, I would look at my next base, which are the v's, so v to the 6th and v to the 3rd. Now here again, I would still add the exponents. So this is going to be v to the 9th. 6 plus 3 is 9. All right, now I haven't done anything with the parentheses yet, so I'm going to go ahead and put the parentheses on with the 2 because I haven't done that part yet. So all I've done is simplify the inside. So now this looks a little bit prettier, and now this looks like day 1 stuff. So how do we get rid of the parentheses? I'm going to distribute the outside exponent to all the exponents on the inside. Okay, so what is the exponent on the negative 3? Because I didn't write it, so I want to identify that. The exponent on the negative 3 is a 1. So you're going to be super careful about that when we're multiplying. So now I'm going to go ahead and distribute because all of my exponents have been identified. I have a 1 on the negative 3, I have a 3 on the t, and I have a 9 on the v. So when I distribute the 2 in, I'm only multiplying it to the exponent. So this would be negative 3, and then 1 times 2 would give me 2. Now this base is a negative number, which means I need parentheses or I'm going to mess this up in a calculator. And we went over this the previous day on why the parentheses are important. But because that base is a negative, I want to make sure I put parentheses around it. Okay, so like in this case, right, when I distributed this 3 in, and I didn't put parentheses around this 3 because this base wasn't a negative number. But if it was, I would want to put parentheses there so I wouldn't mess up later on. Okay, and then I'm going to go ahead and keep going. So multiply the exponents together. So I have t to the 6 because 3 times 2 is 6. And then I have v to the 18 because 9 times 2 is 18. Now I'm almost done. Not quite done yet, right? I would be finished, but there's something I can simplify. I can simplify the negative 3 squared. Well, when I type in negative 3 squared in a calculator, I should get positive 9. So I'm going to get positive 9, and then t to the 6 is going to stay, and then v to the 18th is going to stay. Now, if you forget those parentheses and you type that in the calculator, you're going to end up with negative 9, which is incorrect. Because what does negative 3 really mean? It means negative 3 times itself twice. So negative 3 times negative 3. So you're going to be really careful about parentheses and all of that. Okay, moving on to number 4. Okay, so again, it's getting more and more complicated. Okay, so you want to make sure you're being super careful. So you look at each thing separately. So I'm going to look at this section separately. So I notice, can I do anything to simplify this section over here? Yes, I can. Now, none of these bases can combine, right? A, B, and C. There's 4 separate bases. None of those can combine, but I can get rid of those parentheses. And I can do that by distributing that fraction exponent inside. Now, just because it's a fraction doesn't mean you treat it any different. It's still a number. Before I distribute, you want to make sure you have identified all of your exponents. Well, all of the variables have an exponent, but the 8 does not. So you want to make sure you made it clear the exponent on the 8 is a 1. So I'm going to go ahead and distribute the exponent into all the other exponents. So I'm going to multiply the exponents together. So this would be 8, and then 1 times a third would be 1/3. Okay, we're going to do the same thing with all of your other bases and multiply the exponents together. So the outside exponents to the inside exponents. So this would be a 1/3 times 12. If I type that in a calculator, I get 4. 12 times a third. You are multiplying because you are distributing. Okay, distribution means multiplication. Okay, you're going to do the same thing with the b base. You're going to have a base of b. 9 times a third is 3. And then c, 15 times a third is 5. Now you would be almost finished with this side. However, you want to simplify that 8 to the 1/3. Well, if I type in 8 to the 1/3 in a calculator, okay, 8, and then remember this button is the exponent button, the a to the b. So I'd type that button and do 1 divided by 3. I'm going to go ahead and turn projector mode so it's a little bit bigger. And I get 2. So 8 to the 1/3 is equal to 2. So I'm going to go ahead and rewrite this so that it's the way it needs to be, right? A to the 4th And I'm actually going to write this all in black so that I can state that it's the same. So a to the fourth, b to the third, c to the fifth. So the only thing I changed was that 2. Okay, now on this side, I haven't messed with this side yet, right? So there's a multiplication side. Now I haven't done anything on this side yet, so I want to look. Is there anything on this side that I can simplify? Yes, I can combine some of this stuff because of the bases. So let's go ahead and do that. So do I have any like bases? Yes, I do. Now you always want to do your big numbers first. So I see that I have 2 and I have -3. So what operation am I going to do in between these numbers? I would multiply them because of that multiplication sign. 2 times -3 would be -6. All right, 2 times 3 will be -6. I'm going to try to use a different color from the other side, so pink. All right, now are there any like bases here that I could combine? Looks like I have some a's that are similar, right? So I have a over here, and I have a to the 1/3. Well, what's the exponent on this a over here? If it's not written, it's a 1. So I would combine these a's together. So the question is, do I add 1 and 3, or do I multiply 1 and 3? I would add here. Okay, between these two a's, there's no parentheses in between them. So I'm just going to add the exponents. So I'm multiplying these a's together by adding the exponents. I know that sounds weird. You're multiplying the bases, but the shortcut is that you would add the exponents. Now, there are no like bases with b, right? So I'm going to keep the b the same because I can't do anything else with that. And then the c to the fourth, no other bases of c, so the c to the fourth would stay the same. Now the parentheses would go away because there's no exponent on here. And if there's no exponent, then it's a 1. And if I were to distribute a 1 in there, nothing would change. So the parentheses can drop here. Okay, so I'm going to go ahead and copy this down. -6, a to the fourth, b, c to the fourth. Okay, so now I have this line. And I have this giant problem here that I need to simplify. So let's go ahead and do that. Okay, now in this line here, there are no more parentheses, right? So I can go ahead and combine like bases with each other. So what can I combine here? Well, I can combine the 2 with the -6. I can multiply those, right? Because of multiplication in the middle. 2 times -6 is -12. So this is kind of like the day before, but we're combining all these rules together, and the problem is a little bit longer than it was the day before. Okay, our next step here. Okay, I haven't used baby blue yet. I want to see any like bases. So I see the a's are similar, so a to the fourth, a to the fourth. The question is, would I add or multiply the 4's together? I would add them. There's no parentheses. I'm not distributing them, so I should not be multiplying. I'm going to add. So a to the 8th. Okay, the next base that I see is in common are the b's. So b cubed and the b over here. Now again, if the exponent isn't written, it's a 1. So I have b to the third times b to the 1, which is going to make b to the fourth because I add those exponents together. And then lastly, I don't know what other color I haven't used yet, so let me pick a different color on my palette here. Let's pick this lime green. So we have c to the 5th and c to the 4th. So let me move over. Okay, well, c to the 5th and c to the 4th, I would add those exponents and get c to the 9th. I would add 5 and 4 together. That is super bright. Oh my goodness. It's crazy. All right. And I have no more like bases, so now I am finished with this problem. So that one took a little bit longer, but you have to look at it piece by piece. If you look at it all as one part, it gets a little bit confusing, so you don't want to do that to yourself. All right, moving on to number 5. There's only 8 problems, so we have 4 left. Number 5, again, you always want to look at it by parts because it makes things a little bit easier. So when I look at this left part over here, nothing I can combine, all the bases are different, so there's nothing I can do. Okay, on this side, what can I do? Well, on the inside of these parentheses, right? Okay, so I'm looking on this side because I can't do anything on that side. On the inside of these parentheses, what do I see? Well, I see 4 different bases. I see -2, m, w, and n, 4 different bases. Okay, but none of those bases are the same, so I can't combine them. So I'm like, okay, let's just get rid of these parentheses then, since I can't really do anything else. Before I distribute this 5 in, because of the parentheses, I want to identify all of my exponents. What's the exponent on the -2? It's a 1. What's the exponent on the n? It's a 1. Okay, and the m and the w already have exponents, so I don't have to identify those. So now I can go and distribute. And once I distribute, those parentheses go away. So when I distribute, I'm multiplying exponent to exponent. So the -2 stays, and then I do 1 times 5, which is 5. Now I want to make sure I put parentheses around this. And the reason why I want to make sure to put parentheses is because that base is a negative number. When I have negatives, it's very particular in the calculator that I put those parentheses there. All right, and I'm going to distribute the exponent to the m, so this would be m to the 20th. I am multiplying because I'm distributing, so 5 times 4 is 20. And then I would have w, 5 times 2 is 10. Go ahead and draw my fraction bar. And then I want to distribute, don't forget about the n, right? Because the n is a base as well, so you want to make sure you distribute it to that as well. So you want to distribute it to here. 1 times 5 is going to be 5. So this is what I have so far, and I'm going to go ahead and copy this on the other side because I still have this. Now, you're like, well, how am I supposed to multiply these together? Remember, how do you write anything as a fraction? Anything as a fraction, right? If I want to write 5 as a fraction, what would I do? I would do 5 over 1. You're going to do the same thing here. So this is really all over 1. Okay? Now you're going to do this thing in math where you multiply across, right? So like, for example, if you have 2/5 times 3 over 4, you would multiply across. So you do 2 times 3, which is 6, 5 times 4, which is 20. So that's how you multiply fractions. You just multiply across. So you're going to do the same thing here. I'm going to multiply across. So I need to combine these two sides. Before I do that, I'm going to go ahead and simplify -2 to the 5 over here. So I'm going to keep this the same, 5m squared to the n over 1 times, now -2 to the 5th power, I'm going to put parentheses around that when I put it in a calculator, -2 to the 5th power, that's going to give me -32. So I'm going to put a -32 here, and then I'm going to leave all of this the same. So m to the 20th, w to the 10th, n to the 5th. Okay, so what else can I do here? Well, I'm going to go ahead and simplify this. I want to multiply across. So now I can multiply across, and that's what I'm going to do. So equals, okay, actually, I'm trying to figure out how to do this so that I can save some room here. We'll figure it out. We'll figure it out eventually, right? All right, so let's go ahead and combine any like bases that we have. So I'm going to move this over to yellow. Okay, so you always want to multiply the big numbers first. So we're looking in the tops of the fraction. So I can multiply 5 times -32. 5 times -32, and I'm multiplying because of this negative sign. So 5 times -32, 5 times -32, it's going to give me -160. So I have -160, oops, it's ugly, -160, okay? Now again, this is all over a fraction. I'm combining the fractions together. So 5 times -32 is -160, and in the numerator I have m's that are like bases, so I'm going to go ahead and combine those, m squared and m to the 20th. Now here I would add my exponents because there's no distributing going on, there's no parentheses, so this would be m to the 22, all right? And then I would look for, again, more like bases. Now, there's no like bases with n in the top, so the n is going to stay the same, and the w is going to stay the same because there's nothing else I can do up there, right? Because there's nothing I combine up here. And then we're going to move down to the bottom, right? Well, it's just 1 times n to the 5th. 1 times n to the 5th, which is just n to the 5th. 1 times n to the 5th, right? There's nothing, we're multiplying across. So this is what I have so far. Now, am I finished with this problem? Why don't you take a look at this? I'm going to fix this w real quick. W to the 10th, right? Yeah. Okay, am I finished with this problem? The answer is no. We have like bases here we want to simplify. There's n's in both the top and the bottom. So I want to simplify this and make sure I reduce this down to the most simple it can be. So the -160 is going to stay the same. Okay, the -160 is going to stay the same. The m to the 22 is going to stay the same. Okay, and the w to the 10th is going to stay the same. But let's do something about these n's, right? So I have an n in the numerator and I have an n in the denominator. Now, how many n's do I have in the numerator? It's not written, so there's 1 up here. So here's the thing where the n's are on opposite sides in a fraction. So you're going to subtract those. So the question is, where are there more n's? There's more n's in the denominator. How many more n's are there? There's 4, because you subtract. 5 minus 1 is 4. Now, are you finished? Are there any like bases anywhere else? No. So you are finished. Okay? So that one is a little bit more trickier than some of the other ones. You got to take it piece by piece, because if we do this all at once, it's going to be very overwhelming. All right, moving on to number 6. Again, you start on opposite sides and then you combine. So I'm going to start on this left side first. Now, before I distribute that 3 in, I want to check inside. Is there anything I could combine in here? Nope, all different bases. So before I distribute that 3 in, I want to make sure all of my bases have exponents. So the 2 doesn't have an exponent, but I know there's a 1 there. The x doesn't have an exponent, but I know there's a 1 there. So I'm going to distribute the 3 in and multiply the outside exponent to the inside exponent. So this would be 2. 1 times 3 is 3. And then I have x to the third power, because 1 times 3 is 3. And then I have y to the 6th. 2 times 3 is 6. Okay, I have my fraction bar. Don't want to forget about that z, because that's still a base. You want to make sure you distribute to that as well. And remember, distribution is multiplication. 3 times 3 is 9. All right, so we've done that side. Now, is there anything else I can do? Well, I can simplify 2 to the third power, right? 2 to the third is going to give me 8, not 6. Those are not the same thing. So I have x to the third, y to the 6th, over z to the 9th. Okay, so this is what I have. So same exact thing as this top area. I just simplified the 2 to the third to make it an 8. Now I haven't done anything with this multiplication sign in the middle, so I'm going to leave that as is. And now I'm going to move on to the right side over here. Now on this right side, before I distribute this 2 on the outside in, I want to look on the inside. So on the inside, it looks like I have 5 different bases. I have 5, x, y, w, and z. But none of these are the same, so nothing I can really combine with, so I'm going to go ahead and distribute the 2 in. Before I do that, I'm going to check for those exponents. Make sure you have all of your bases have an exponent. The exponent on the 5 is a 1, the exponent on the x is a 1, and the exponent on the w is a 1. So when I distribute those in, I want to make sure I get those correct, because you don't want to mess up on these on accident. So I'm going to distribute this in. So 5, and then 1 times 2 is 2. Distribute that in. So 1 times 2 here would be 2 again. Okay, now y is a base. Now your exponent on the y is 1/2, but you're still going to do the same operation. You're distributing, so you're going to multiply. 1/2 times 2 is going to give me y to the first power, y to the 1. Okay, and now I have 2 bases in the bottom. I don't want to forget about those. So you would have a z in the bottom, or w, I'm sorry. So we're going to have w, and then 1 times 2 would be 2. And what color have I not used yet? I feel like I've used a lot of these. I'll use this burgundy color, okay? And then I have z, so I'm going to multiply those exponents together. 2 times 2 is 4. Now, is there anything I can simplify here? Okay, well, I can't do anything with those variables, but I can do something with that 5 to the second, right? What is 5 to the second? 5 to the second is 25, right? 25. And there's nothing else I did to the other, so I'm going to leave those as is. I'm going to go ahead and write the 1 there, just to help us out later on. Okay, we never know if we need it. So w squared, z to the 4th. So I didn't change anything from this step to this step. I just made the 5 squared become a 25. So now I'm at this step. Parentheses are gone. Each side has been simplified as much as possible. So now it's time to multiply across. Just like when we do 1/2 times 3 over 4, you would multiply across. 1 times 3 is 3. 2 times 4 is 8. We're multiplying across, okay? So you look for like bases to multiply together. So 8 is a like base with 25. I can multiply those together. So 8 times 25, you're multiplying because of this multiplication sign. So we have 8 times 25. That's going to give us 200. That's a big number, 200. Okay? So I'm multiplying across, so I have 200 so far. Okay? Now, do I have any other like bases in the numerator? Yes, because remember we're multiplying across. So like we're not even looking down here yet. You're just looking up here. Okay, so I have like bases with the x's. So I have x cubed and x to the second. Well, x cubed and x to the second, would I multiply the 3 and the 2, or would I add the 3 and the 2? I would add these because there's no parentheses. I'm not distributing the 3 and the 2 together. I'm just combining them and making 5. 3 plus 2 is 5. Okay, moving on. I see that I also have a base of y in both fraction numerators. So I'm going to go ahead and combine those together. Y to the 6th and y to the 1st are going to make y to the 7th together. I would add those together. Okay, the shortcut is that you add those exponents together. Then I have my fraction bar. And then I will look in the denominator, see if there's any like bases here, which I do have, right? I'm going to go ahead and let's use pink. So I have z. Oh, goodness. Okay, I have z over here, z to the 9th. And then I also have another base of z in the denominator over here. So I want to go ahead and combine those together. Well, z to the 9th and z to the 4th, I'm multiplying the z's together, but the shortcut is I would add those exponents. So 9 plus 4 is 13. Okay? And then that w squared, there's no like bases with it, so I would leave it exactly as is. There's nothing I can do to it. Okay, so I'll just leave it in the denominator. Now, how do you know you're finished? When you have no bases that you can combine together. Doesn't look like I have any, so I'm finished with this problem. There's nothing else I can do. All right, now the last two problems are application problems. These are super important that you know how to do these. Super important. You hear me? Super important that you know how to do these. Okay, so we need to know how to do both of these. So, number 7, find the area of a triangle. And they gave you the formula, area of a triangle is 1/2 times base times height. So we're going to find the area of this triangle over here. They gave us the base and they gave us the height. So we're going to plug it into this formula, okay? So I'm going to go ahead and identify this for us because we get confused sometimes. The base, which would be this, okay? That's the base. And then the height, which is this, okay? And then we have the 1/2. So I'm going to go ahead and plug this in the formula. Area equals 1/2 times the base. So the base is the pink, so 6x cubed, y, z to the 4th. So what's the hardest thing about these problems? They don't set it up for you. You have to be able to interpret this on your own. So 1/2 times the base times the height. What's the height? Well, they gave that to you. That is 5x to the negative 1, y. So this is what I have so far. Now you're going to apply your laws of exponents to this. The laws of exponents are just the same as always. The first thing I always like to start with are the regular numbers. So what regular numbers do I see here? Well, I see a 6 and I see a 5. Now I'm going to multiply these together. I don't like how this is orange. Let me change this real quick. No, let's change. Yeah, let's do that. Make this blue. It's just a little bit easier to see. I'm sorry. Give me 1 second. Okay. So, oops. This needs to be blue. That's the height. Okay, there we go. All right. So, 5 and 6 are regular numbers, but so is a 1/2, right? A 1/2 is still a regular number. It's just a fraction. So I'm going to do a 1/2 times 6 times 5. I'm combining these numbers and multiplying them together because they're all being multiplied. So I would do 1 divided by 2, a 1/2, times 6. And you want to make sure you tack outside the fraction so that you're not in the bottom anymore. Times 6 times 5. A 1/2 times 6 times 5 is going to give me 15. So what do I have? I have 15 here. And then you're looking for like bases. So it looks like I have some like bases here. I have x's that are the same base. So I have x cubed and x to the negative 1. Now we haven't seen negative numbers yet, but they're still numbers. So the question is, would I multiply 3 and negative 1, or would I add 3 and negative 1? I wouldn't even subtract because it's not a fraction, right? So I'm either adding or multiplying. So I know I have an x. But here I would add them. You're not distributing, right? There's no parentheses. You're not multiplying, so you're going to add them. 3 plus negative 1 is going to give me positive 2. 3 plus negative 1 is positive 2. Then you're looking, do I have any more like bases? Yes. We have the y here and the y here as well. I want to go ahead and combine those. Well, what's the exponent on each of these y's because it's not there? The exponent on both of these is a 1. So then I have a y to the first times y to the first. So y times y, that's going to be y squared. I would add those exponents. 1 plus 1 is going to give me 2. Okay, I would not multiply because there's 2 of them there. Now the question is, what about that z? Well, there's no like bases with that z, so I'll just leave it alone. It'd be z to the 4th. So, what did I just find? I found the area of this triangle. So I did what I needed to do. I did a 1/2 times the base times the height, and I simplified it as much as possible. So the area of my triangle is this expression right here. Doesn't look pretty, but it's not supposed to because you're using a bunch of variables. All right, now lastly, number 8, if the area of a rectangle is 18a to the 6b to the 4th, and the height is 3ab squared, what is the base? Okay, it says the area of a rectangle is this, and the height is this. What is the base? Well, let's talk about the area of a rectangle for a second. How do I find what is the formula for area of a rectangle? Well, the formula for area of a rectangle is length times width. Well, did they use length and width in this problem? Do you see length and width in here? No. What did they use instead of length and width? They used height and base. So let's go ahead and change this to area equals base times height. Okay, base times, same thing, same concept, right? Base times height. Okay, now let's think about this. They gave us the area, right? They gave us the area, and then they gave us the height, but they didn't give us the base, right? So let's go ahead and plug in the information that we know. So I'm going to highlight the information that I know real quick. So I'm going to highlight the area is 18a to the 6th, b to the 4th. So I'm going to go ahead and plug that in the formula. So I'm going to write the formula here. Area equals base times height. I'm going to plug in the area on the a side. Remember, a stands for area. So 18a to the 6th, b to the 4th. Okay? Equals base. Well, do I know the base? I don't know the base, right? So I'm actually going to use a capital B here because it looks like there's already B's being used here and I don't want to confuse those. So I'm going to use a capital B for base. And I'm going to use a capital H for the height. So area equals base times height. Go ahead and get rid of that. Base times height. Okay, do I know the base? I do not. I don't know what the base is. So I'm going to keep the base as big B here. I don't know what B is. Okay, now, do I know the height? Because that's the next thing in the formula. I plugged in the A, so right, I plugged in A for area. I don't know B, but I do know the height. I'm plugging stuff in my formula. Just like in the last one, I plugged stuff in. I had a half times base times the height. So here I have area equals base times height. Don't know what the base is, but I know that the height is 3ab squared. So I'm going to go ahead and plug that in. 3ab squared. Now it's base times height, so put a little multiplication there. So it says, what is the base? So what am I looking for? I'm looking for the base. I'm looking for that blue B, okay? I don't know what that blue B is. I need to solve for it. So anytime in math when you're looking for something, you want that something to be by itself. So how do I get the baby blue B to be by itself? I got to get rid of all this stuff over here. So now you got to think back to solving equations, right? How do I get rid of this stuff? Well, right now it's being multiplied to B. So what's the opposite? You're going to divide it out. So we're going to divide out 3ab squared. We're going to get rid of this, the whole thing, so we can move it to the other side. So this side's going to be 3ab squared. So what do we have? We have 18a to the 6th, a to the 4th, divided by 3ab squared equals our b. That's all that's left on that side. So what did we do? We wanted to get rid of this because it's being multiplied to the big B. So in order to do that, we have to do the opposite and divide it out. So you have a little bit of mixture of solving equations here. Okay, so have I finished solving for the base? Sort of, right? We got the big blue B by itself. However, we need to simplify this stuff over here. So what can we simplify? I'm going to go ahead and move this over there. Well, what can we simplify together? Well, looks like I can combine the big numbers together, right? 18 and 3. Now, 18 and 3 are normal numbers, okay? They're normal numbers. So what is 18 divided by 3? Because this is a division bar. 18 divided by 3 is going to give me 6. 18 divided by 3 is 6. And then you look for more like bases. Which have I used yellow yet? Yes, I have. I'm going to use this little lavender color. All right, I have a to the 6, and I have like bases with, whoa, where'd that other a come from? Oh, my gosh. I'm sorry, you guys. You guys are probably yelling at me through the thing. I didn't even notice. That's supposed to be a B. I copied it down wrong. That's a B. Okay, I was like going really crazy for a second. I was like, where'd that extra A come from? All right, and there's an A here. Now, what is the exponent on that A? There's an exponent of a 1 there. There's an exponent of a 1. So here's the thing where you do. Where are there more A's? There's more A's in the top, so it's going to go with the 6, right? Because really, this is technically all over 1. Okay, how many more A's do you have? You have 5 more A's in the top. Okay, so the previous day we talked about how really there's a fraction, right? 18 divided by 3 is 6. To write 6 as a fraction, it's 6 over 1. So you can write the over 1 if you'd like, if that makes you feel more comfortable. All right, and the next thing would be, let's see what color I can use. I feel like I've used everything. I've used dark blue. All right, well, the B's are like bases. I have B to the 4th, and I have B to the 2nd here. Never mind, I'll fix that later. Okay, well, where are there more B's? There's more B's at the top. How many more? there's 2 more. So you're subtracting. Why are we subtracting and not adding? Because they're on opposite sides. You would add when they're in the same row together. You would subtract when they're in a fraction like this. And this is equal b. So, do you have any like bases that you can combine left? No. So you're finished. So the base of your rectangle is 6a to the 5th b squared. So what is the base? We just solved for the base. So they gave us some information. You got to be able to plug it in and set it up yourself. So make sure you know how to do that problem. If you have any questions, please feel